Greeting class. Today's class will be on grade 11 mechanical technology, and today's topic is going to be engineering forces and mechanical principles. We'll be focusing on engineering forces and mechanical principles. We'll now look at our objectives after this lesson, so what you as learners need to know after we have concluded with our lessons. Our lesson objectives are as follows. Learners should be able to identify and describe the type of forces, to understand Newton's laws of motion, analyze effects of forces on materials, apply mechanical principles such as levers, pulleys, and gears, and solve force-related problems, and to understand problems that deal with equilibrium, and perform simple practical experiments, and to be able to relate it to the real-world applications. So now we're gonna find out what is a force. A force is a push or pull upon an object. It causes an object to move, stop, or change directions, and is measured in newtons, depicted by the letter capital N. We have types of forces, such as the tensile. Tensile means pulling apart, and compressive means pushing together, and shear means sliding of layers. Torsional means twisting, and lastly we have the bending. That's the combination of tension and compression. Newton's law of motion states that an object stays at rest or in motion unless acted upon by an external force, and is measured by force F is equal to mass times the R0 ratio, measured in newtons. It states that for every force there is an equal opposing force. That's the first law of Newton's. And we have the stress and strain. Our stress is equal to force over area measured in newtons per meter squared. And our strain is change in length over original length. And we have elastic and plastic deformation. Now we'll look at our mechanical principles. We'll be looking at our levers, the types and examples, pulleys, fixed and movable systems, gears, spare, lever, and worm gears. Now we'll be looking at the mechanical advantage, which is MA is equal to load over effort. And the velocity ratio of it is distance moved by effort over distance moved by load. And we'll check the efficiency to check if the machines worked at 100%, but mostly you can never have a 100% efficiency of any machine. There will always be some technicalities, so it's not possible that on our mechanical advantage we'll possibly get 100 in most factors. There will be small factors that are affecting the efficiency of the machine. So don't be expecting to get 100% of efficiency of any machines. And now we're going to look at the vector diagrams and resultant forces. Vector diagrams and resultant forces. Our vectors are represented by arrows. We are using arrows to represent our forces. whether it's positive or it's from tail to head or head to tail. And we use scale and direction because that time the scala because it has both magnitude and direction. And to find out the resultant, we'll be using a triangle or a Pythagoras theorem. Whatever resulted or even a Pythagorean method. Now we'll be looking at the conditions that qualify for an object to be at equilibrium. The sum of all forces has to be equal to 0, and the sum of all moments has to be 0, applied in beams and structures. So we have balance. So right now I'll be taking you through steps when we'll be performing our practical experiments. Step number 1, you have to measure force using spring scale and calculate mechanical advantage of a pull of a system. Observe material deformation under load. In our real world applications, when we are looking at mechanical principles, we are looking at bridges and buildings, vehicles and machinery, tools and mechanical devices, safety considerations in design. Now, be a chance for you to ask questions on the comment bar below there. You can ask me questions. I'll see when to get back to you. So that's about it. That's also our lesson today. That's our